I was thinking about what really separates someone who just uses a computer from like a power user.
Oh, yeah.
Yeah, there's this moment, right? A kind of threshold you cross where it stops being this magic box you just poke at.
And starts being something you can actually conduct, like an orchestra.
Exactly. Orchestrate is the perfect word. And looking at the notes for Class 4 from the CS123 System Admin course, I feel like this is that exact moment.
It really is. We're looking at the spring 2026 material on foreground, background, and advanced scripting.
This isn't just how to list files anymore, is it?
Not at all. It's a huge pivot. I mean, up until now, everything has been very linear. You type a command, you hit enter, you wait.
You wait a long time sometimes.
Exactly. But today we're kind of shattering that whole idea. We're going to get into multitasking, persistence, and how to write scripts that actually, interact with you.
I'm glad you brought up the waiting because honestly, the default way the terminal works sometimes drives me crazy. I call it the hostage situation.
Hostage situation. I like that.
Yeah. I need to find a file in some huge directory or maybe compile a big program. I type the command, hit enter, and that's it.
You're stuck.
I'm stuck. Just a blinking cursor. My whole terminal is held hostage until that one thing finishes.
That is a perfect description of foreground processing. It's synchronous.
Yeah.
The shell sends your command off and then just waits. It ties up everything.
It feels so inefficient. I've got all this computing power, and I could only do one thing.
Well, that's where we have to intentionally break the default. We need to do things asynchronously. And the notes introduce this with a really simple but powerful symbol.
Ampersand. The enact.
That's the one. You just tack it onto the end of your command line.
So my big grep search, and then a space, and then...
That's all it takes. The shell starts the job, but then, and this is the key, it immediately gives you your prompt back.
So it's running, but I can keep working.
It's running. You'll see a little message pop up with a job number and a process ID, a PID. It's the system basically saying, got it, here's your ticket number, go do something else.
Okay, that solves the hostage crisis.
Yeah.
But what about the scenario that happens to me all the time? I forget.
Yeah.
I hit enter on some huge 10-minute task, the cursor just hangs, and I have that oh no moment. My instinct is just to hit Ctrl+C and kill it.
Which is painful, right? Because you lose all the progress it made. But you don't have to kill it. You just need to push it aside.
But my terminal is frozen. I can't type.
You can't type a command, but you can type a control key, specifically Ctrl+Z.
I've used that, but I honestly thought it was just another way to kill a program.
Nope. And this is a really critical distinction. Ctrl+C sends what's called a SIGINT, a signal interrupt. It tells the process to die.
Okay.
But Ctrl+Z sends SIGTSTP. It's a terminal stop signal. It tells the operating system to suspend the process.
So it's not dead, it's just paused.
Exactly. It's frozen in time, still in memory. All its state is preserved. It's just not using the CPU anymore.
All right, so I've hit Ctrl+Z. I've suspended my long-running task. I've got my prompt back. But now I just have a frozen process sitting there. How do I get it running again, but in the background this time?
Simple. You just type big.
Big for background.
You got it. You type big, and the system takes that job that you just suspended and tells it, okay, wake up, but stay in the background. It's like you retroactively added the ampersand you forgot.
That's a lifesaver. Seriously. So now I might have a few things running in the background. How do I, keep track of all of them?
Good question. You use the jobs command.
Jobs.
It'll just list everything that's currently running or stopped that's attached to your terminal session.
And what if I need to bring something back to the foreground? Like say I accidentally backgrounded a text editor like Vi. I can't really type in it back there.
Right. Interactive programs need to be in the foreground. For that, you use FG. For foreground.
Just FG on its own?
FG will bring back the most recently backgrounded job. If you have a few, the jobs command gives them numbers, like job 1, job 2. So you can say FG+1 to be specific.
It's really like juggling then. You're throwing tasks into the background and then pulling them back down when you need to interact with them.
It is, you're orchestrating. But there is a massive trap here, a huge pitfall for anyone new to this.
Oh no. What is it?
I call it the disconnect problem.
You mean like when my VPN drops or the Wi-Fi cuts out?
Exactly that. Or you just close your laptop to go to a meeting. When that terminal session disconnects, the system sends a special signal to all the processes you started. It's called SIGUP.
SIGUP, that sounds weirdly old.
It is. It stands for signal hang-up. It's a total relic from the days of dial-up modems when you literally hung up the phone line.
And I'm guessing the system's reaction to a hang-up is not good.
It's to kill everything.
Yep.
The logic is, well, the user is gone, so these processes must not be important anymore. So that backup you had running, that was 90% done.
Oof. Gone.
Gone. Oh, that's just devastating. How do you stop that?
You have to wrap your command in a protective shell, and that shell is called no-hep.
As in, no hang-up.
Precisely. You just type no-hep before your big command. It basically tells that process, hey, if you ever get a hang-up signal, just ignore it. Pretend you didn't hear it. Keep going.
Okay, but if my terminal is closed, where does all the output go? If it tries to print to a screen that isn't there, won't it crash?
That's a great question. No-hep is smart. It knows there's no terminal, so it automatically redirects all the standard output into a file.
What file?
It just creates a file called nohub.out, right in whatever directory you're in.
So I can come back later, open that file, and see everything it did while I was gone.
That's the idea. True fire and forget system administration.
You know, speaking of checking on things, I'm definitely guilty of this. I'll have a job running, and I'll just keep typing peace. Wait a few seconds. Type peace again.
The nervous admin twitch, we've all been there.
Notes have a cure for that, right? The watch command. Oh, watch is fantastic for that. You just type watch and then the command you want to run over and over, like watch papes.
And it just reruns it for me.
Every 2 seconds, by default, it clears the screen and shows you the fresh output.
Yeah.
But the real magic is the why the D flag.
What does that do?
Watch D highlights the differences between updates. So if a file size changes or a process finishes, that line just lights up on your screen.
Yeah.
You don't have to hunt for what changed. You can just see it.
Okay, that's incredibly useful. So we've got a handle on managing the environment now. We can juggle tasks, keep them running. I want to shift gears to the other big part of Class 4, advanced scripting.
Right. This is where we move from just typing commands to actually building our own tools.
And the notes start with functions. Now, let me be the devil's advocate here. Why do I need a function? Can't I just write my script as one long list of commands?
You can, sure, but you'll regret it. Imagine you have a chunk of code that, say, checks if a user's directory exists, and you need to do that check 5 different times in your script.
I just copy and paste it 5 times.
And then you find a bug in your logic.
And I have to go find and fix it in all 5 places, and I'll definitely miss one.
Exactly. A function lets you write that logic once, give it a name, and then you just call the name. It's cleaner, it's easier to maintain, it's just better practice.
The syntax looks mostly familiar. A name, parentheses, curly braces. But passing arguments to them looks a little odd.
It's a little bashy for sure. You don't name the variables in the parentheses. Inside the function, you just grab them using $1 for the first one, $2 for the second, and so on.
Just like the script itself gets its arguments.
Right. And that leads us to probably one of the most powerful but maybe least intuitive commands for this shift.
The notes really emphasize shift. I've always had trouble visualizing what it's actually doing.
Okay, let's use an analogy. You're a ticket taker at a movie theater. You have a long line of people.
Okay, I'm at the door.
The person standing right in front of you is $1. You take their ticket, you process them, they go inside. Now, what do? Do you walk down the line to the next person?
No, I stay put. The line moves.
The line moves. The person who is number $2, steps forward and becomes the new $1. That's what shift does. It throws away the current $1 and makes everything else slide down one spot.
So in a loop, I can just keep processing whatever is in $1 and then call shift, and the next thing in the list will be ready for me.
Precisely. You can process a list of 10 file names or 10,000 file names with the exact same code. It's incredibly efficient.
And to get those file names, we might need to talk to the user. That brings us to making our scripts interactive.
The read command.
Right. It just pauses the script and waits for you to type something. But there are a couple of really cool options in the notes. I love ready.
The timeout option. Yeah, that one's fun.
The example is great. It asks the user for a response, but only gives them 5 seconds. If they don't answer in time, the script just insults them and moves on.
It's great for automated systems where you want to give a human a chance to step in, but if no one's there, you want it to proceed with a default action.
And the other one is ready S.
For silent or secure, you absolutely have to use this if you're asking for a password or an API key.
Because it stops the characters from showing up on the screen as you type.
Right. Very important security practice.
Okay, so we've got input. Now we need the logic, while loops, and the logical operators. The notes focus on and S.
The double ampersand and the double pipe.
I always just thought of them as AND and OR, but the notes imply there's more to it, like a safety feature.
There is. It's called short circuit evaluation, and it's a huge deal.
Okay, explain that.
Let's take AND, which means AND. If I write command A and command B, The shell runs Command A first. If Command A fails,
It doesn't bother with Command B.
it stops right there. It never even tries to run Command B.
Because if the first part of an A and D is false, the whole thing can't possibly be true.
Logically, yes. But think about the practical safety of that. Imagine your script says, cd some important directory and nrm.
Okay, change directory and then delete everything.
Right. What if that directory doesn't exist? What if the cd command fails?
Ooh. If you just used a semicolon, it would fail the CD and then happily run rm in whatever directory you were already in.
Which could be your home directory. You could wipe your own account.
Oh, wow.
But with nrm, if the cd fails, the arm is never, ever executed. It's a critical safeguard.
So Anrin is a safety gate. Anbrin is the opposite.
It's the error handling version. It runs the second command only if the first one fails. So you can do things like connecto database, echo, error, could not connect.
That makes the script so much more robust. It's brilliant. Which I think brings all of this together in that big example in the notes, the etc/pass crude script.
This is the grand finale. This is where you see how all these pieces, functions, loops, logic combine to do something really powerful.
Walk me through what it's doing.
Okay, so first, it uses a while loop in read to ask the user for a search pattern. It's actually in a loop that won't let you continue if you just hit enter.
So it forces you to give it some input. Good design.
Then it takes your pattern and uses grep and awk to search the system's password file and pull out a list of matching usernames.
So the list it's working with is generated on the fly.
Exactly, it's not a hard-coded list. Then it enters another loop. For every single username it found, it calls a custom function to, say, process that user's files or check their directory permissions.
So it's a script that's reacting to the current state of the system and then taking action. That's a whole other level.
It's true orchestration, and that is exactly what listeners are going to have to do for Lab 4.
The homework. Let's get into the details.
Okay, so this is a big one. It's a graded lab. You have to take the script you started in Lab 3 and expand it.
And it has to include these new concepts.
Absolutely. The requirements are clear. It must use functions that you define. It must use the shift command to process arguments. It must use a while loop. And it must get input from the user with read.
There's a big, bold warning in the notes for this one.
Yes. And everyone needs to pay attention to this. Your script must be non-destructive.
What does that mean, practically?
It means be terrified of commands like arm inside a loop. If you get your logic slightly wrong, a script can delete hundreds of files in less than a second before you even realize what's happening.
So the advice would be to maybe use echo first, like echo, I am about to delete this file, instead of the real command, just to test the logic.
100%. Always test your logic by printing what you would do before you actually let the script do it.
That is solid advice. So when is this due?
It needs to be posted on the spring discussion boards. The specific form is Student Assignment Posts Week 4 Bash Script. The deadline is next Wednesday, February 18th by 1:00 p.m.
February 18th, 1:00 p.m. And don't be that person trying to debug an infinite loop at 12.55.
Please don't.
You know, before we wrap up, looking at all this together, no hup, these complex loops, it kind of sparks a bigger thought for me.
Oh, yeah.
We're essentially teaching people how to make the computer act on their behalf when they aren't even there.
It's a form of delegation, absolutely.
Yeah. But it's more than that. I mean, think about it. You write a script with all this logic, all these decision points. You start it with no hup, you close your laptop, you go to sleep.
And the script keeps running.
It keeps running, it's making choices, it's creating files, maybe deleting them. It's acting with your authority, but completely without your supervision.
The ghost in the machine.
Yeah. It's like you've bottled up a piece of your own judgment and just left it to haunt the server.
That's a great way to put it. It's both incredibly powerful and, yeah, a little terrifying.
It really is.
It all comes back to that old admin saying, the computer does what you told it to do, not what you meant for it to do. And when you leave that ghost running unattended, you better be very, very sure you told it the right thing.
Because you don't want to wake up and find out your friendly ghost decided to clean house.
Exactly.
All right, on that slightly spooky note, I think that's all we have time for. Good luck with Lab 4, everyone. Watch out for those loops, and we'll see you for the next deep dive.
Happy scripting.